Hi guys, welcome back. I hope everything's going well. I've got a few notes here posted that you can take a look at with me. First thing I want to talk about is the fluency test number 5, the at-home version you took the other day. I'm going to grade that and I'm going to put it on Infinite Campus just like I would any other fluency test. When I grade it, I'm only going to circle and mark problems you got wrong. I'm not going to tell you what's wrong about them because you get to go back and you can actually fix them and improve your grade. In fact, you can go back and fix any assignment. If you do that, email it to me. So here's the process I want to follow. When I first assign something, I want you to go ahead and submit that to Schoology like you've normally been doing. Once you submit it, I'm going to grade it, put that grade on Infinite Campus. Once it's on Infinite Campus, if you fix it, I'd prefer you to email it to me so I can see it quicker, and then I will just fix the grade on Infinite Campus. Okay? Guys, remember, if you're not doing anything, if you've taken the few days off, you're going to see incompletes all over the grade book. You can still get an incomplete for this class. I can't emphasize that enough. Meaning that you will not get credit for it, meaning you'll either have to take it next year or over the summer. Okay, so make sure you're doing stuff. Make sure you're contacting me if something goes wrong, your computer crashes or something. You can't submit it. Something new down at the bottom, each Bronco day. So every day that we meet, I'm offering an office hour. It's going to be from 10 a.m. to 11 a.m. every Bronco day. It's going to be on Zoom. The directions are on the distance learning plan page, that document that I put on Schoology. Feel free to stop in and say hi, ask a question, just see how everything's going. I'll be there for an hour. You don't have to stay the whole time. You can pop in for a few minutes, ask your question, and then leave. And that's how it's going to work every Bronco day from 10 to 11 a.m. Okay. So today we're going to look at some stuff on page 426. We have 2 videos I'm going to post. This is the first one. Go to your book, page 426. And I've got some things here for the word wall. Now, if you're still keeping your word wall, feel free to add these on. But a rational function, we added this on the word wall already, but we're just reviewing this one, is in this form, right? A quotient of 2 polynomials. Horizontal asymptotes we've seen before, but we're going to see them more and more in our graphs today. Horizontal asymptote y equals a. This happens at the end behavior. So way out to the left, way out to the right of a graph. The vertical asymptote is an x equals because it's a vertical line. This happens when a function increases without bound. That just means it keeps going, either up or down. And the reason those are important today, we'll see, is because the graphs of these rational functions will always approach or get very close to all of its asymptotes. So you'll see when we graph these guys that we're going to approach these. When we go up, down, left, or right, the graph of these rational functions will always be approaching their asymptotes. Okay, so today I want to start off with this problem. This is, see if I can get back up to the top here. There we go. All right, so this is in your book, number 2. And what they're doing is they're giving you the graph already. And what we can kind of see where the vertical asymptote's happening here. And what they want us to do is complete this table so that we can find or kind of visualize where the horizontal asymptote would be. So let's do that. Go ahead and pause the video here if you can. Take a minute or two and fill out this table. You're plugging those x values into that f of x you see at the top of the page. Okay, so if you did that, if you plug the values in, you should, and you can use a calculator for this, you should see 3.97 when you plug in negative 300, 3.92, 3.85, plug in negative 20, I get 3.64, negative 10 gave me 3.33, and then some positive numbers, I get 5, 4.44, and I plugged in 50, I get 4.17, I plugged in 100, I get 4.08, and I plugged in 300, I get 4.03. Now, we could keep going with this table, but here's what it wants us to see. We'll kind of split the positives and the negatives here. As the x's get really big negative numbers, right, left far on the graph, you can see that my y values here are starting to get really, really, really close to 4. Now, you can keep plugging in big negative numbers, negative 1,000, negative 1,000,000, and the y value will never actually hit 4. And you can see that happening right here on the graph, right? We're getting close and close to 4. Closer and closer to 4, we're approaching it. Now, on the other side, right, as I come over here to the right and start plugging in big positive numbers, look what happens. still approaching 4, but now it's approaching 4 from the top. So my horizontal asymptote, we kind of proved this on the table, is this horizontal line right here at y equals 4. We saw that from the table. Now we'll talk about how to see these later on. You can kind of see where this vertical asymptote is here at x equals 2. And the vertical asymptotes are easier to see. The horizontal asymptotes are a little trickier, but we'll talk about that on a later day. Okay. There we go. So you just did that. The equations for the two asymptotes we have back here. The horizontal asymptote in red was y equals 4. And the vertical asymptote in blue was x equals 2. So y equals 4 is x equals 2. What do you notice about the equation of the vertical asymptote in relation to the denominator of the function? So if you look back at this function, you see that x minus 2, you notice that that's our restriction. So the asymptote, the vertical asymptote, is the x restriction from the denominator of fx. All right, so that's what we're looking for. Though that's why we've been working on those restrictions on x for so long. Those are going to turn into our vertical asymptotes. Not always, but for right now, for today, that's what's going to happen. Okay, let's take a try. Let's try this one. This is very similar. We'll go through this step by step just so you can see the process here, and then we'll try one on our own. So, first question is this a rational? Is this function of r of x a rational function? And the answer is yes. It is the quotient of two polynomials. We have a polynomial 2x minus 9 up top, and we have a polynomial x plus 3 in the denominator. Okay. Letter B says, for what value of x is the function undefined? This undefined happens when x is negative 3. What does this tell us? This is the vertical asymptote. All right, simple as that. Letter C, kind of like we did in the last one. Pause the video here, take a second, and start plugging in these values, big negatives, big positives, and let's see if we can't guess what the horizontal asymptote would be. All right, so here are the values I get. When I plugged in negative 300, I get 2.05, and I get 2.15, I get 2.32, I get 2.88, I get 4.14. When I plugged in negative 5, I get 9.5. Plugged in 10, I get 0.85. I plugged in 20, I get 1.35. Plugged in 50, I get 1.72. 100 gave me 1.85. And then 300 gave me 1.95. Okay, so let's look at the extremes here, right? When I go to negative 300, looks like I'm getting close to 2 coming from the top. When I go to positive 300, again, I'm getting close to 2. This one's coming from the bottom. That's going to help me when I graph it in a second. So my horizontal asymptote, we'll call it HA, is going to be y equals 2. Okay. Now, we haven't talked about this yet. This part's new. We want to find the x and the y intercepts. Now, for the x-intercepts, we have done this consistently throughout the whole year. We always let y equals 0 to find the x-intercept. And that doesn't change at all with these rational functions. I go back to the original r of x. I plug in 0 for y. I get 2x minus 9 over x plus 3. And I'm back to solving a rational equation like we did on fluency test number 5. So this only has one denominator, so I'm going to multiply both sides by x plus 3 over 1, x plus 3 over 1. Right? My goal here is to get rid of this denominator, which I do. There we go. And that gives me x plus 3 times 0 on the left side is just 0. And here I get 2x minus 9. So if I clean that up, solve for an x, I get 9 over 2, which means my x-intercept, remember x-intercept is a point, so we want to write as an ordered pair as 9 over 2, comma 0. Now you can call that 4.5, comma 0 if you want, because that's a nice decimal. All right. So our technique to find the x-intercept, we plug in 0 for y. Our technique to find the y-intercepts are always a little easier in these types of problems, is let x equal 0, just like we've been doing all year. So we go back to r of x. I'm going to actually use y instead of r of x. It'll be easier to see. Y equals, if I plug in 0 for x, I get 2 times 0 minus 9. And then on the bottom I get 0 plus 3. So I get 0 minus 9 over 0 plus 3. Now I'm showing every possible step here. You probably can see what the y-intercept is a little quicker. I get y equals negative 9 divided by positive 3 is negative 3. So my y-intercept is 0, negative 3. Okay, so that's how you're going to find x-intercepts, and that's how you're going to find y-intercepts. Now, to sketch a graph, let's use the information we already know. We know the vertical asymptote's at negative 3. Let's come over here to x equals negative 3, and we're going to sketch in a vertical asymptote. We know the y-intercept is y equals 2, so we're going to sketch in a horizontal asymptote at y equals 2. We got that from the table today. We're going to do that other ways later. It's actually quicker. We're going to find that quicker later on. Now, let's look at the x and y-intercept. For the x-intercept, we had 4.5, so 4.5 comma 0 is right about there. For the y-intercept, we had negative 3. So negative 1, 2, 3 is right about there. Okay, so 2 points that we did using the x and y-intercept. So remember what we said about these asymptotes. These rational function graphs are going to approach these asymptotes when you go left, right, up, and down at all the extremes. So I already have 2 points in here. I know for sure that I'm going to approach the asymptote here. I'm going to hit those 2 points, and I'm going to come up and approach the asymptote going out there to the right. So I can guarantee that's what my one piece of this graph is going to be. Now, I'm not done. I've got to figure out what's going on elsewhere, okay? Now, I know nothing can go up there. If you think back to what we know about functions, this graph has to pass the vertical line test. If I put something up there, it's not going to pass the vertical line test. The other piece of this graph has to be either over here or over here, okay? Now, I don't know where. It could go up top, it could go down low. But if you look back at your table, we have some hints there. Look back at your table, when we plugged in negative 5, we got 9.5. So we go to negative 5, negative 9.5, boom, I'm up there. If I look back at the table, negative 10 was 4.14. So negative 10, a little bit above 4, is up there. You can see this other piece of the graph is in this top left corner. Now you can't see really on this graph what's happening, but remember, when I go up to the top here, that thing is approaching that vertical asymptote. When I go, let me see if I can just get rid of that little circle I made. Okay. When I go far off to the left, way over here, this guy's going to approach this horizontal asymptote. So these rational functions always approach at the horizontal and vertical asymptotes as you go to extremes. Way to the right, way to the left, way to the top, way to the bottom. That's important because I can't see this. If you graph something like this, right, like loop, like that, that's not a rational function because that's not approaching the horizontal asymptote way off to the right. Okay, that's it. So here's what I think we should do now. Let's pause the video. This is on page 428. There's an example, check your understanding number 7. So we're going to do answer some questions. We're going to sketch a graph. You can use the graph of the right above there just for number 6 because we're not going to do that right now. But pause the video, see if you can identify the asymptotes for this guy, the x and y intercepts, and then sketch a quick graph. All right, so vertical asymptote, easiest one to find, comes from the denominator right there, x minus 3. The restriction there is 3, so the vertical asymptote is at x equals 3. For the horizontal asymptote, the only way you know how to do that right now is by making a table. So if you start plugging in big numbers, right, we know there's going to be a y equals something. Just do a quick table over here, all right? Start plugging in big numbers, like let's plug in 10, right? If you plug in 10 to f of x, you're going to get 12 over 7, right? If you plug in, that's a little bit over 1. If you plug in 100, you're going to get 102 over 97. That's even closer to 1, right? Bigger that x value gets, the closer and closer and closer those y values are getting to 1, coming from the top. The decimals for those y values might be easier for you to see. Now go negative. If you plug in negative 100, you're going to get negative 98 over negative 103. That's really close to 1 as well. If you type that decimal into the calculator, the difference is though that value for 1 is coming from the bottom. Negative 98 over negative 103 is a little bit less than 1. But both of these values, the positive numbers for x, the big positive numbers for x, and a big negative number for x, both approach positive 1. So my horizontal asymptote's at 1. Okay. Now, x-intercepts. X-intercepts, we plug in 0 for y. If I plug in 0 for y here, I get 0 equals x plus 2 over x minus 3. I multiply both sides by the denominator, x minus 3. Now, you're going to see a pattern here. The x-intercepts will always come from the numerator of this fraction, if there's just one fraction. So you got to be careful. But if I multiply both sides by x minus 3, and x minus 3, on the left side I get 0. On the right side, those x minus 3's reduce, and I get x plus 2. So my x-intercept is at negative 2. Write it as a point, negative 2 comma 0. The y-intercept, plug in 0 for x, you get y equals, now you can probably do this right away in your head. If I plug in 0 for x here and there, both of those x's go away, or just turn to 0. So I get positive 2 over negative 3, which is my y-intercept, 0 comma negative 2 thirds. Okay, so I got an x-intercept, I got a y-intercept. I have horizontal, vertical asymptotes. Let's see what I can do with that. So my vertical asymptote was at x equals 3. So 1, 2, 3 right there. My horizontal asymptote was at 1. So y equals 1 right here. Okay. I've got an x and y intercept. I get an x-intercept at negative 2. So x-intercept negative 2. I got a y-intercept at negative 2 thirds. So right about there. So I know this branch. Each little pieces of these graphs are actually called branches. So I know this first branch is looking something like this. And I know the second branch, so up to over here, I don't know exactly what's going on, depending what values I plugged in. Let's look over here, I plugged in 10, I got 12 sevenths. So remember that was a little bit bigger than 1. If I plugged in 100, I got 102 over 97, that was also bigger than 1. So what I know is that this piece is up here. Now I could always make an XY table and plug in some more points to get a little bit more accurate of a graph. But right now we're just sketching rough graphs. Make sure that these graphs have bends to them. Make sure they approach the vertical asymptotes and horizontal asymptotes to the right, to the left, and the up and the down. And you can get a pretty good graph. All right, that's it. Your homework for this section is to complete this marble slides activity. It's on Desmos. The directions are in the digital learning plan document I put on Schoology. For full credit for this assignment, you got to complete each challenge by getting the stars and then make the 4 predictions. You do that, you get credit for this assignment. Okay, I hope to see you guys at the Zoom meeting, And feel free to email me with any questions too.